Hello, welcome to the Math Dive in 5 for kindergarten, representing numbers up to 20. Let's dive in. We are going to dive into our very first task for the day. So first, know that you are going to discuss what you see on the bottom of the slide when it comes up with your partner or with your team if you're watching with your team. You're going to think about and talk about what the difference between each representation is. And you're also going to anticipate which examples your students are going to have success with and why. So out of the 4 examples you see, which do you think are going to be the easiest for your students, and why are those going to be the easiest? I also want you to think about which examples are going to be the hardest for your students. So out of the 4, which ones are your students going to struggle with that you already know you're going to need to support your students a little bit more with understanding. So after the examples come up, you're going to go ahead and pause the video and take a look at the examples, think about the 3 questions above, and then unpause when you're ready to move on. Here are the 4 examples. Here you can see we are going to talk about the progression with the best standards and why what we do is important in kindergarten and then how it affects first grade, the next grade level. So here, this is a big chunk of time for us. We are doing a lot in this unit. We're counting to 20. We're representing 20 in different ways. We're reading and writing 20 with pictures and objects. The very big piece here that we want to focus on today for the Dive in 5 is that understanding numbers greater than 10 are made up of a unit of 10 and a group of ones. So that's really the piece that we're going to focus on today. And then thinking about how that affects first grade. It affects first grade because then they're going to be moving into numbers up to 100 with composing and decomposing, especially when they're adding and subtracting, when they learn to regroup, and also combining ones and tens to compose new tens from ones when adding. That is going to be a direct connection to what we are doing today. All right, so remember we had to do a couple of things with the task. We had to order them as easiest to most difficult, and then think about which ones would be easy for our students and which ones would be more complex for our students. So as I was ordering them, I was thinking for my kiddos, I would go right from example 1 to 2 to 3 to 4. And so thinking about example 1, that's the concrete model. So of course that I think is going to be the easiest because the students actually have the tools in front of them. They can see the full 10 frame and how it's 110 and then the 7 ones, the 7 leftover ones right afterwards. Example 2 I thought would be the next easiest or the next difficult for my students because we are thinking about 17 is the same as 10 ones and 7 ones. So that's not quite grouping the 10s together yet. We're still thinking about it as 2 separate 10 frames. We have 10 ones in this 10 frame and 7 ones in this 10 frame, and when we put them together to count, they make 17. Example 3 was 110 and 7 ones, and so I thought that was a little bit more difficult because now if a student is showing that way, then that is representing that group of 10. So they're actually starting to group those 10 ones together to make 110 instead of saying 10 ones. So that's a little bit more complex. And then I thought example 4 would be a little bit trickier because they're looking at the ones first and then the tens. Whereas usually we're guiding our students to look at the full 10 frame and then the leftover one afterwards. I know a couple people that flipped example 2 and 3, and that is perfectly okay. I definitely see the sequence that way as well. There's no right or wrong answer. Just thinking about the why behind each of the example is the important component. All right, so looking at the concrete models, we are building the foundation for place value with our students. So I think that's the most important thing you can remember here, that we are the foundation, the building block for the rest of what happens with place value. with our base 10 system. So we want to make sure that our students have multiple experiences with building those concrete models. Here are a couple of examples with the concrete models. This is the 10 frame we saw with the yellow counters before in that example 1. It looks exactly, like we had the full 10 frame and then the leftovers. And then if you see the example with the red counters, you can see it's grouped kind of the same. It just doesn't have another 10 frame with it. So you can have your student, you can start with 2 10 frames, and then you can move into 1 10 frame and having the leftover ones afterwards. You could switch. So the kids are starting with the full 10 frame and then having the leftovers, and then adding that second 10 frame in to have students place the leftover ones in. It doesn't matter which way you start, but having the conversations of what we do with the leftovers in the group of 10 is going to be the most important. And here's just another example with some Unifix cubes. You can use snap cubes in the 10 frames as well. So students can then start to see, here's a group of 10, the leftover ones, and then they can start to group them together when they're building. And so when they're building, I grouped it by 5, and 5 you can see the 5 yellow, the 5 blue, and then the extra ones, which is the 7 ones. So these all represent 17 in different ways. They get a little bit more complicated each time, and really we want to have our students eventually see this very last way where the group of 10 is stacked together, so they know this is 10, and then the 7 ones after the 10, one group of 10, 7 ones left over is 17. So thinking about how they all represent the same number, how can we use these representations to help us say the number 17? I know we think there's just one way to say the number 17, but thinking about those 4 examples that we worked with, we want to make sure we are modeling how to say the number 17 with one group of 10, 7 ones left over, 10 ones, and 7 ones, etc. So making sure that we're modeling for our students the different ways to say the number 17 will help when they're representing and sharing their experiences afterwards. Here's just one quick pictorial model. We know that one expectation of the standard is that students can represent numbers to 20 with drawings as well as with tools. So of course the pictorial representation comes along right after. We can see that we have a group of 10, we've got the 7 ones left over, and so thinking about that next component of that example, like number 4, how can I get the kids to think about the ones and the group of 10 afterwards? So let's think. So asking students to say, like, how do you see this number represented, and letting them share. So hopefully, like, thinking about a student saying, I see a full 10 frame, so they see the full 10 frame on the top and 7 extra ones, and that makes 17. Another student might say, I see a 10, and that's great because that means they're already starting to group that full 10 frame together, and 7 ones, and that's the same as 17. I see 10 ones and 7 ones, and I know that is 17. So again, so thinking that student isn't quite grouping the 10 ones into a group of 10 yet, and that's okay. If they can, see how another student grouped it by saying 1 10 and 7 ones, that would be helpful for them. And then a way to try to get them to see the ones first is simply by flipping it upside down, just like you see here. By flipping the 10 frames upside down with having the bottom one originally, that was the leftovers, that kind of guides students to be able to see it in a different way. And so then I see 7 ones and 1 10, and that's still 17. So making sure we're hearing all 4 of those different ways from our students. If students don't come up with that at first on their own, it is okay. We can always prompt them to say, if nobody said, I see the full 10 frame and 7 extra ones, you can always say, what about, does anybody see a full 10 frame? And what about the extra ones? Can somebody share that way? So really, again, the prompting with our questions is going to be very important in this unit. And here, finally, we know our ultimate goal is to get students to be representing abstractly with numbers up to 20. At this point in the year, students don't have to write their own equations or expressions. We can support students who are ready to create their own expressions and equations by asking them to write numbers with their tools and picture models. That is perfectly okay, but it's not an expectation that we have to have of everyone. So these are just 2 examples. You can see the concrete example with the yellow counters with the 10 frames. If a student were to write 17 is the same as 10 and 6, like you see in the blue, that would be perfectly okay. Also, in the red, we have 17 equals 110 and 6 plus 6 ones. Again, great examples to be seen from your students right now. Here's also the pictorial representation. Again, if students are in the pictorial understanding, you can always ask them to write down what they're seeing and see if they are ready to move on. And if so, then great. So a couple misconceptions that I wanted to talk to you about before we are all done for the day. We know counting with teen numbers is hard. And it's hard because there's not a sequence. Like 11, 12, and 13 are different, well, and 15 are different from a sequence where you hear 14, 16, 17, 18, 19, where you actually hear the ones place represented when you're saying the number. The more you can count with your students, the better, and that will just give them practice. You can also use printed number cards by the models and drawings students create to let them see both the numeral and the visual model together, and that will start to help them with that. And we know it takes a little while for them to get those naughty teen numbers down. Students may also struggle with the concept that one group of 10 ones and some more ones can represent the same idea as the number that was originally counted. So thinking about all the different ways we saw the number 17, they might struggle to say 110 and 7 ones left over. And again, it's okay. The more we can compose those groups of 10s, thinking about going to the Unifix cubes or the snap cubes, and actually have them put those 10s together and then have the leftover ones, that will help them see that group of 10 together. All right, so we are on our last slide. We want to remember, we want to take our students through the concrete, representational, and abstract way of thinking. When we're in the concrete thinking, we don't want to just stick to 10 frames. We want to make sure we move into letting the kids group those 10s together so they have that practice and they can see this is a group of 10 and these are the ones left over. And then moving into the representational, the drawings, and then finally the abstract way of thinking with some expressions and some number sentences and some equations. Thank you so much for joining our representing numbers up to 20. I hope you can join us for our next unit, which is comparing and ordering numbers up to 20. Have a wonderful day.